Hello everyone. Today's question is about errors and approximations, and in particular calculation of percentage error. Well, the question reads, the volume of a cuboid is 40.3 cubic centimeters to 1 decimal place, and the base area is 8.71 square centimeters, correct to 2 decimal places. Then part A, find the limit of error in calculating the height of the cuboid. And then lastly, find the percentage error. So for the first part, in order to determine the limit of error in calculating the height of the cuboid, we need to consider the following. We are told that the volume of the cuboid is 40.3 cubic centimeters, that is to 1 decimal place, and the base area is 8.71 square centimeters, correct to 2 decimal places. Well, the question is about the height of the cuboid, so the limit of error in calculating the height of the cuboid. We know that from the formula, volume is equal to base area times height. The height will be obtained as volume over the base area. So when you calculate the height h, we need to consider the errors in determining V, that is the volume, and the error in determining the base area. So the limit of error in calculating height of the cuboid will be based on the volume, which is 40.3. So we're told that is to 1 decimal place. And even if we were not told, we can see already it's to 1 decimal place. So error is usually calculated as plus or minus a half times the least unit of measurement. And the least unit of measurement here is 0.1. Remember, it's to 1 decimal place, so we can have 0.1. So this is the least unit of measurement. So you just have plus or minus a half times 0.1, and that is plus or minus 0.05. So that implies that for the volume, we have 40.3 plus or minus 0.05. We also need to consider the one for the base area. Now for the base area, we have 8.71. Remember, this is for the base area. And the error here should be plus or minus a half times the least unit of measurement here. So the least unit of measurement will be, we have 0.01. So we multiply by 0.01, and that is plus or minus 0.005. The base area will be 8.71 plus or minus 0.005. So the limit of error in calculating the height of the cuboid will be for the base area and for the volume, just as shown. We are required to find the percentage error. Percentage error is obtained as relative error times 100, but remember, relative error is absolute error over the actual value times 100. That is for the percentage error. Now what we are interested in here first is how to determine the absolute error. Absolute error is given as the absolute value of the maximum value minus the minimum value divided by 2. And for this case, we have a quotient. Remember, we are finding the percentage error in determining the height of the cuboid. So H, that is the actual one, is the volume, which is 40.3 over the base area, which is 8.71, and this should give us 4.6269. But we need to know the maximum value of H. Maximum value of H will be obtained as the maximum value of 40.3 over the minimum value of 8.71. Now, before we determine that, I wish that we first of all determine the limits. So for the volume 40.3, we have the upper limit as 40.35. Remember, we had the limit of error as plus or minus 0.05. So we are going to add 0.05 to 40.3 to get the upper limit and subtract 0.05 from 40.3 to get the lower limit. That's how I've obtained 40.35. I've added 0.05 for the upper limit, and then for the lower limit, we subtract and get 40.25. And then for 8.71, we'll have on the upper limit, we're going to add 0.005 and get 8.715. And for the lower limit, we subtract so that we get 8.705. So using these here, we'll say for maximum value of H, we'll have the maximum value of 40.3, which is 40.35 over the minimum value, which is 8.705. So we have the minimum here and maximum there, and that worked out should be 4.6353. And then for the minimum value of H, we are going to have the minimum value on the numerator, and the minimum here is 40.25, and then the maximum value on the denominator, and the maximum value for 8.71 is 8.715, and this should be 4.6185. Now, from here we can determine the absolute error. Absolute error is the maximum minus minimum over 2. So maximum is 4.6353 minus minimum 4.6185, and then we'll have to divide that by 2, and that of course gives us 0.0084. So from here we can determine the percentage error. Percentage error is equal to absolute error over the actual value. So absolute error is 0.0084, and the actual value of H we had gotten as 4.6269. We had worked it out here. Now this should give us the relative error, and then we multiply that by 100 so that we get the percentage error, and that should be 0.1815%. So that is the percentage error in the calculation of the height H. Now with that, we come to the end of this problem. Thank you for watching. Bye.